In this video, we'll be talking about balancing ion charges in ionic compounds. Say we have the compound iron 3 chloride. What does the iron 3 ion look like? Remember that the Roman numeral indicates the charge on the iron because iron is a transition metal and can have several charges. So iron 3 is Fe3+, because metals always form cations, or positively charged ions. They lose electrons. What does the chloride ion look like, and what is its charge? Chloride is Cl-. Compounds that are stable should have a net zero charge. So how do we determine the correct chemical formula for iron 3 chloride? Well, if we start by adding one iron 3+ and one Cl-, that would give us a net charge of 2+. But if we add two more Cl-, we have 3+, plus minus 1, plus minus 1, plus minus 1, or a net charge of 0. So 3 Cl- will balance out the Fe3+. So the correct ionic chemical formula is iron Cl3. This chemical formula indicates that for every 1 mole of iron Cl3, there's 1 mole of iron ions and 3 moles of Cl-, because it required 3 Cl's to balance the charge on the iron. Let's try another one. What if we have aluminum oxide? So aluminum is weird in that it's kind of on the right side of the periodic table, but it's technically a metal. So as we get lower on the periodic table, right on the edge of the transition metals, there's an imaginary staircase that goes down. And aluminum is the first element on that staircase that represents a metal. So those are often called the metalloids. But aluminum is below the staircase, making it a metal. And it requires the loss of 3 electrons to make aluminum behave electronically like its nearest noble gas. So it will lose 3 electrons and form aluminum 3+. What does the oxide ion look like, and what is its charge? Well, oxygen can gain 2 electrons to look a lot like its closest noble gas. So we have oxygen 2-. How do we balance these, and what is the chemical formula? Well, if we start with an Al3+, and we add an oxygen 2-, we have a net charge of +1. If we add a second oxygen 2-, now we have 3+, 2-, and 2-, or -1. So let's add another aluminum 3+. Now we have 3 plus 3 minus 2 minus 2, or a net charge of +2. If we add one more oxygen, we're left with O2-. What is now the chemical formula? Now that we're balanced, we have a net charge of 0. This gives us Al2O3 for aluminum oxide. This means that for every 1 mole of aluminum oxide, there are 2 moles of aluminum 3+ and 3 moles of O2-. Note that these subscripts by elements also indicate the same thing for covalent compounds, even though we're not dealing with ions. So if we had something like CH4, even though this is a covalent compound or molecular compound, it's not made up of ions. For every 1 mole of CH4, there's 1 mole of carbon atoms and 4 moles of hydrogen atoms.